One last thing on the JFETs issue. There are circuits like these, that are based on setting up a constant current source with a bipolar transistor, and that's supposed to minimize the parameter spread, um, because it ensures a constant current through that, and therefore a constant voltage drop across it. So, um, and a baseline for the current. I assume the device itself can, that you got to limit the current source to less than obviously the current the JFET, what its IDSS is. But supposedly, this can, reduce a lot of the, uncertainty factors with JFETs, except that it's still not going to do anything about, what your transconductance is, on the input. And like I said, that alone, is a huge spread. But at least this does minimize some of the ambiguity, by having a circuit similar to this. And I may build this at some point to test it out, but not right now. But at any rate, I just, for sake of completeness, thought it'd be worthwhile to, mention that. And if you go to ESP, Elliott Sound Products website and read on there, his JFET sections and stuff. He has a lot of circuits like this, like constant current sources and stuff like that, to give you gain amplification. Because that's one of the problems with a JFET, generally speaking, is there's not enough gain to work with. They're pretty low gain devices. So like with a bipolar transistor, you usually have betas, of 100 to 250 or so, just with a plain Jane transistor, and that's a lot of gain to work with. So you can use feedback, all right, to actually reduce the gain, but also stabilize the thing against different, you know, devices. So you can drop another device, even from a completely different transistor, into it if you want, and still get similar performance, depending on your amplifier design. But you just can't do that. You can't use any kind of feedback, for this sort of thing at all. So, um, I mean, if you take, this one for example, and I did actually build and test this circuit. Like I said, basically they've got, a split arrangement here and bypassing part of the, the most of the biasing resistance, but using some of this, uh, for gain stabilization, and it's like degenerative feedback. So, it's actually feeding back some of the signal back into it to reduce the gain. So the gain ends up, being pretty much, this 150 ohms into this 4.7 kilo ohm, resistor with no load on it. Now, if you do have a load, you got to, parallel the load resistance and the collector resistor there, and then divide that by this resistor, and that gives you the actual gain. But as a result, you could swap in a lot of different transistors, with an amplifier like this, which happens to have a gain of about 15, um, and and get like substantially the same result. So, but you cannot do that with FETs because they just do not have enough gain, and again, the ESP guy talks about that. They just don't have enough spare gain for you to do that kind of feedback with. So as a result, there's really not a lot you can do, about the transconductance, being different from just even, device to device in the same part number like I showed. So you're going to have, a lot of differences. Even if you do something about some of the other parameter variations, you still will have that to worry about. So anyway, I just wanted to make that clear. So anyway, cheers.